Let's talk really quickly about GMOs. You're talking about Roundup already. It sounds like you think some use of GMOs might be completely fine in the sort of diverse system that you're imagining. Is that right, or do you feel like there's an argument against GMOs generally?
Well, I think that, the one point that I think often gets lost is that the technology is way overhyped. Like what it can actually do is overhyped. And in most cases, conventional breeding is just as effective, and it's not any slower, and it's a lot cheaper. It's a lot cheaper of a technology. So in a
By
kind of
conventional, you mean non-GMO,
Yeah.
or organic?
or non-GMO.
Just non-GMO, okay.
Non-GMO plant breeding is actually very, very powerful and is a lot cheaper, and oftentimes is better. If you think about something like, my critique of GMOs is this, that when the industry started in the 70s and 80s, there was this idea in biology that one gene corresponded with one trait. There's this one gene, one trait idea. And it seemed really powerful. If you could move a gene from one organism into another, you could just move that trait over, right? And so what it turned out, though, is that processes like the way that a plant takes up water, the way that a plant uses nitrogen, the way that it converts nitrogen into plant growth, these are incredibly complex processes, and there's not one gene that does that. I was talking to a cotton breeder at Texas A&M, which is a big state land grant university, and I was asking her, like, just throwing her a softball question, like, why don't you take a gene from a cactus and put it into corn, and that way you get this incredible drought-tolerant corn? And her response was great. It was like, well, once you do that, there's not one gene that controls the way that the cactus takes up water. And so you start moving one gene over, and then another gene over, and then another gene over. And by the time you've got something that actually works in the field, you've got cactus again. You've taken the whole genome over, because that's how complex things are. And something like corn has been cultivated and domesticated for thousands of years in a place like Mexico, under a whole variety of different growing conditions. Really dry ones, really wet ones, really high altitude ones, really low altitude ones. And in the corn genome, if you go into Mexico and look at all the different varieties of corn, you've got in that genome, you've got drought tolerance, you've got you've got salt tolerance, you've got water tolerance already there. And there's no magic gene that is going to make plants drought tolerant. And in fact, Monsanto has a drought tolerant corn on the market. It doesn't work any better than corn that's already adapted to dry conditions. And so, I think that's the problem with it, is that it's overhyped, and there's usually other alternatives that are faster, cheaper, and better. There are some situations like the citrus greening situation, where there's this fungal pathogen that's attacking citrus crops in Florida, and it's spreading through most of the citrus world, and it's really hard to control. And there are GM solutions that are showing promise, but even those GM solutions that are showing promise, the pathogen will ultimately outwit it, and you're gonna be on this treadmill. And so it isn't clear that, but I would think that in that area that it's worth a shot to try GMs. Right. But I think there are also other non-GM solutions that are also worth trying. And I think that's what's happening down in Florida, is that they're just trying everything.